Hello friends, myself Professor Dilip Tathe, Senior Lecturer from Padam Shri Dr. Vittarao Vikhe Patil Polytechnic, Pravaranagar. Today we are going to study the chapter named as heat transfer. So first of all, consider the concept of heat transfer. What is meant by heat transfer? Let us consider the example of hot potato or boiled eggs. So when the hot potato or boiled eggs is kept in a room temperature, you experience that after some time the potato gets cooled down. That means the temperature of the potato will be decreases. So why the temperature of the potato decreases? That means heat is transferred from hot potato to a room. Let us take another example. Consider hot cup of coffee or tea kept on a table in a room temperature. So naturally after some time the coffee or tea gets cooled down. That means it is transferred from hot coffee to the room. Next, when we consider the IC engine, petrol or diesel engine, after the starting of IC engine, the engine gets heats up due to the combustion of fuel, and it is continually generating the heat, and heat from the petrol or diesel engine is transferred to the atmosphere, dumped in the atmosphere. Next, if you consider the example of sun and earth, here again also the heat is transferred from the sun to the earth. So these are some of the examples of heat transfer. You may understand the concept of heat transfer. Next, we will study the definition of heat transfer. Heat transfer is defined as the transmission of heat energy from one region to the another region due to the temperature difference between these two. That means temperature difference is necessary. If the temperature becomes equal, then there is no heat transfer. Okay, so heat always transfer from higher temperature region to the lower temperature region. It never transfer from lower temperature region to the higher temperature region without the aid of energy, without the supply of energy, according to the second law of thermodynamics. It is just like as fluid flow. Fluid never flow from lower level to the higher level. It always flow from higher level to the lower level. Again, heat always flows from a warmer, hotter place to a cooler place. Okay, that means higher temperature to the lower temperature. Hot objects in a cooler room will get cool to a room temperature. Vice versa, cold object in a warmer room will heat up to a room temperature. So if you kept a cold water, refrigerated bottle in a room, so after some time the temperature of the cold water will be increased. So what are the different modes of heat transfer or the heat transfer mechanisms? There are three modes of heat transfer. Number one, heat transfer by conduction method. Number second, heat can be transferred by a convection method, and heat can be transferred by a radiation. So we will study one by one what is heat transfer by conduction, convection and radiation. Here the heat transfer mechanism is illustrated, explained here. When you heat up the hot metal on a flame, so the temperature of hot metal rod at one end will be heated, and the heat is transferred from one end of metal to the another end of metal, and other end of the metal will also heat up. So this mode of heat transfer is called as conduction. Next, if the heat is transferred through a fluid, then it is called as a convection, and if the heat is transferred through a air, then it is called as a radiation. So what is the conduction mode of heat transfer? It is the process of heat transfer from one particle of a body to another particle in the direction of falling temperature. That means heat conduction will take place through solid only. Okay, means through metal only. So one particle will be heat up, it gives the heat to the another particle will be give the heat to the next particle, and thereby the heat is transferred from one end or face to the other end or face. Same thing here, heat conduction may take place through solid, liquid and gases. Conduction of heat is due to the vibration of molecules, but the particles remain fixed position related to each other. For example, when you touch a black car in a summer season, the heat from the car will be transferred to your hand. Next, if you feel the cold in a winter season, because the cold air transfers into your body, the metal conducts heat from the cup of warm water to the cup of cool water. So these are the examples of conduction. As I told you that if a cup of coffee was left on the table in a room, what would be happen and why? So after some time the cup of coffee will cool until it reaches to a room temperature. That means until the temperature gets normalized. So next mode of heat transfer is a convection. Convection is achieved through a fluid. Keep in mind, conduction achieved through a solid or a metal, convection achieved through a fluid. So it is a process of heat transfer during which heat energy is carried out from one part of fluid to another part of fluid by the actual movement of heated mass of the fluid. The motion of the fluid is caused by the differences intensity which results from temperature difference. Next, third mode of heat transfer is radiation. You can take an example of sun and earth where heat energy from the sun is received to the earth without any media or with the media air. So for radiation no media is required. Solid, liquid or gaseous, no media is required. Heat can be transferred through vacuum also. So it is a process of heat transfer from hot body to a cold body in a straight line. In a straight line without affecting the intervening media. That means no media is required. For example, solar radiation heats up the earth. Heat from the sun radiates through empty space to earth. So here is the example of sun and earth. Heat energy gets from the sun to the earth. There are no particles between the sun and the earth, so it cannot travel by conduction or convection. Some of the questions regarding radiation. Whether radiation travels in a straight line, whether it is a true or false. So it is a true. Radiation travels in a straight line. Can radiation travel through a vacuum? Yes, radiation can travel through a vacuum. It is a true. Whether radiation requires particles to travel, there are no need of particles to travel. So it is a false statement. Can radiation travels at the speed of light? Yes, radiation can travel at the speed of light. It's a true. So one of the practical example is that why the houses are painted by a white color in hot countries or hot regions. Sometimes the roof of the house will be painted by white color in a summer weather condition. So why it is? So answer is white color reflects heat radiation more than other color, than other body, and it keeps the house cooler. Which of the following is not a method of heat transfer? So you know there are three types of method of heat transfer: radiation, conduction, convection. Here, insulation is not a method of heat transfer. There is no heat transfer through insulation. In which of the following are the particles closest together? Whether in solid, the particles are closest together, whether in liquid or whether in gas. So, in solid, the particles are closest together. How does heat energy reaches from the sun to the earth? Whether it reaches through irradiation, conduction, convection or insulation. So, through radiation, heat energy reaches from the sun to the earth. Which is the best surface for reflecting heat radiation? So, best surface for reflecting heat radiation is a white surface. Most of the heat radiation incident, sun radiations incident on the white surface will be reflected. So in white there is again a shiny white is the best reflecting medium. Which is the best surface for absorbing heat radiation? Next point, which is the best surface for absorbing heat radiation? So black body absorb most of the heat radiation. Black body. Here again dull black is more effective. More heat will be absorbed. So if you wear the black cloths, then black cloths absorb more heat. So there are three laws of heat transfer. First one is Fourier's law, which is related to conduction. Next one is Newton's law of cooling, is related to convection, and Stephen Boltzmann's law is related to radiation. So first of all, we'll study the Fourier's law of heat conduction. According to Fourier's, the scientist Fourier's, the heat transfer rate depends on the temperature difference, varying indirectly proportional to the area of cross section, perpendicular to the heat flow, and inversely proportional to the length. That means according to Fourier's, heat transfer rate is directly depend on temperature difference. How much is the temperature difference between two surfaces? As well as it also depends upon the cross section of the object and inversely proportional to its length. So mathematically, according to Fourier's, rate of heat transfer Q by A is directly proportional to the dt by dx, where Q is the amount of heat transfer, heat flow. A, capital A, is the cross section area of the object. dt, change in temperature or temperature difference, and dx is the thickness of the body which the heat flows. Again, this expression can be written as, by eliminating the symbol, proportionality symbol, we can write it as Q equals to Ka dt by dx, where K is proportionality constant known as thermal conductivity of a metal, A cross-section area dt by dx, temperature difference and change in that. So here K is constant of proportionality known as thermal conductivity of body. So as the value of K, thermal conductivity, is large, it can be considered as a good thermal conductor. Whereas if a substance has a small value of K, thermal conductivity, it can be considered as a poor thermal conductor, or it can be considered as a good thermal insulator. Okay, thank you. In next lecture, we will study about the next mode of heat transfer, that is convection. Thank you.